So, check. Alright, everybody, here we are looking at 5 safety safe 41 stacko frac situation here. And the way we're going to deal with this is multiplying by the reciprocal, but simultaneously I'm going to start trying to factor everything I can. It looks like this top, the numerator's numerator, I can factor out a 5, so I'd have 5 times x squared minus x minus 6. Looks like what we'd have. Over, and in this denominator, I kind of would like to have it in standard form. I'm going to factor out a negative 15, I think. And then I'll have positive x and negative 3. So that's one of the ones by factoring out a negative, you can kind of change the signs a little bit, make things a little nicer. And then I'm multiplying by the reciprocal of this denominator. For the denominator's denominator, I'll factor out a 4. Alright, and that's my new numerator because of the flip. And looks like I'll factor out a negative 1 here, giving me positive x squared negative x minus 6. So I can, I suppose, start canceling some stuff out already. So the minus signs will undo each other. 5 goes into 5 once and into 15 thrice. And the x minus 3's will cancel out. And then I've just got to factor these things. Factors of 6 that subtract to be 1 are going to be 2 and 3. Oh wait, better yet, I don't even have to factor those. Why is that? They are factorable, but I can actually cancel those out in their current state since they are completely identical. So that would save me a little bit of time. Oh, and then behold, 1 times 4 is 4, and 3 times 1 is 3. Lo and behold. There we go. So, any other questions I can help you guys with? Gladly. I'm even fine doing a problem that we didn't have assigned, if you spot anything that's of interest to you. Hola, senor. Welcome, welcome. So you guys really good at factoring? Is there a factoring skill you'd like me to... Yeah, good idea. Where did I... Aha. Yep, definitely willing to open up the table here. Oh, yes. Yeah, number 11 was a sneaky one. That actually conveyed... oh, wow. I think there's... every single piece of number 11 is tricky. It's like you got to be a master bomb defusal expert to pull this one apart successfully. The first thing I might do is I've got a fraction. Actually, I'm kind of sad that their vinculum isn't extended like this. And then I would make this the Mondo vinculum. And then this denominator, I'm dividing by y squared plus 9. But it might be better to put that over 1. So my multiply by reciprocal concept will be a little bit more obvious to us. So let's start trying to factor any of this stuff. So this is equal to, now y to the 4th minus 81, I'm going to pretend is y to the squared squared minus 9 squared. And that's going to simulate a difference of squares pattern. Okay? Let's see. Now, for this 4-termed expression here, unless we could GCF all 4 terms, usually the only way they might happen to be factorable is if you can factor by grouping, which is kind of like pretend it was in the middle of an AC method right after we split the B term. So I'm going to factor out the GCF from the first 2 terms, which looks like would be y, and I'll factor out the GCF from the last 2 terms, which would be 3. And I'll have y plus, nope, so let me slow down here. Y times x plus 4, and then factoring out the positive 3 would be x plus 4. And conveniently, those x plus 4's match. Now, if they didn't, we would be in trouble. And I'm multiplying by the reciprocal of the denominator here. So that's y squared plus 9, which is not factorable. Okay? There's no such thing as the sum of two squares pattern. It is just straight up not factorable. And if I was trying to solve the equation y squared plus 9 equals 0, both of my answers actually would have been imaginary, if you were wondering. But so let's take this a little further. So up top here, this will be y squared plus 9 times y squared minus 9. All right, using the difference of squares pattern, right? A plus b times a minus b is what I'm, because that was equal to a squared minus b squared. Yeah, so all sorts of factoring skills coming into play. Glad we're doing this one. And then we'll have y plus 3 times x plus 4. Let's see. Sometimes my x's look a little sad. Multiplied by, I guess, 1 over y squared plus 9. And looks like I could cancel out the y squared plus 9s. And y squared minus 9 can be factored, because there is a difference of squares pattern, once again, like up top. So that one actually had multiple layers of factoring within it. So that would be y plus 3 times y minus 3, all over y plus 3 times x minus 4, and then the y plus 3s. Yep, x plus 4. Thank you. And so my answer is y minus 3 over x plus 4. So yeah, that is a good one for sure. And then I do want to point out that problem 12, in this case, they actually gave us something that was already factored, x plus 2 cubed. So that's kind of helpful. But sometimes students are then tempted to like multiply it all out, and then they realize that that took them further from their solution. So it's not as helpful as you'd think. Later we'll talk about how to do problems like 10. I'm not quite sure why this was hiding in this problem set. But yeah, so any other questions I could do on anything that's going to be on this quiz? Yeah, let's do another graph thing. Yep. Let's see. I'm assuming we didn't do some of these even assignments. Let me do 32. 32 looks interesting enough. So graph the rational function. So this is 32 from page 554 from the concept of graphing rational functions. The first thing that might be valuable in order for us to figure out domain and range is factoring this denominator. What does that factor to become? Yep, x plus 1, x minus 1. So that's helpful for figuring out the domain. So what values of x would break this? Yeah, so x cannot equal -1, x cannot equal +1. Right? Now the range, now it doesn't look like this will have anything that cancels out, which is where you have graphs that have like the little holes showing up in them. So this is kind of more of a regular kind of rational function, I guess is what I'd say. So I do expect this to have a horizontal asymptote. And the way I would do that is analyze the leading terms between these two. And I've got a higher degree in the denominator, so what value of y wouldn't work? 0 because the denominator is growing faster than the numerator is kind of the explanation there. So y cannot equal 0. So in terms of asymptotes, this is asymptotic at x equals -1, which is a vertical line, x equals +1, which is a vertical line, and y equals 0, which is a horizontal line. So if I want to graph this, I will have, I'll just give some space here. So here's -1, here's +1, y equals 0 is the x-axis. And now I just got to figure out, is it like this and this and this? I've got to really figure out where these things exist. And oftentimes what we'll do is make a table of values so you could plug in your numbers and figure it all out. Sometimes you can do it through a little bit of sign analysis. In this case, because it happens to have a horizontal asymptote at 0, I could consider large values of x in both negative and positive directions and try to figure out, is it going to be above or below. But that doesn't work if I had like a horizontal asymptote here, because even if it was positive or negative, it wouldn't actually tell me anything since both of them are going to be positive in that case. So let's make a quick little table of values, which on the quiz, those will be generated for you automatically. Let's see. Opening this up. And there we are. So let me define my y function. So it's x divided by x, let's see, squared minus 1. Alright, so A3 is my x value for that particular point. So I hit enter, and it's a little bit laggy. A little laggy this morning, not going to lie. And I'm going to double click, sending that down once it realizes its end. Come on, Excel. Alright. Oh, there it goes. Yeah. And let me grab a snapshot. So in order to really just figure out what's going on between some of these values, let's do this. So as x approaches negative infinity, what is the y value approaching? 0.1, 0.01, 0.001. It's approaching 0, and notice all of these are negative, so it's approaching 0 from underneath. So that tells me that I've got this situation going on here. Alright. It's getting closer to 0 from the underside. As x goes really positive, this also verifies that it's approaching 0, 0.1, 0.01, 0.001, and this is approaching 0 from above, so graphically speaking. It would look like that. And now I've just got to try to figure out what's going on between -1 and 1, and sadly this isn't very helpful for us. But we can plug in some numbers here. Aha! Oh! Interesting. This gives me actually one very important fact. So y equals 0 will still be an asymptote, but it turns out y can equal 0, and it does right there. So it turns out, I know it crosses here, so it's either one of these situations where it's going to be like that, or it will be like this. So the only way to figure out that is I need to plug in like 0.5 and -0.5 to really know for sure. So that means my domain, or sorry, range hasn't in fact changed. It looks like y can be anything. But that's okay. We couldn't really know that until we looked at the table, or if we were expert masters at analyzing just the equation, you might have been able to figure it out. So let's see. Let's plug in some values there. So let me plug in like I'm just gonna overtake this. So I'll have -1. Oh man, might be just faster for me to do this on a calculator. Let's see. -0.5 is mystery. Aha, positive. So it's the positive up here. Wrong color. So positive. And I know, well, I guess it's possible it could do a ricochet. So I do have to figure out what is going on after that. And let's plug in like positive 0.5, 0.5, blam. And yes, if you didn't have it on your chart, you could just plug in, right, like calculate the values by plugging in 0.5 in for all of the x's and evaluating it. And that one was equal to -0.6, so it does in fact do the crossover and like that. So interesting little graph there, in fact. So that's a pretty good general sketch of it. All right, I'm not looking for anything super accurate. Technically, we could take some of these values and plot points, but I'm more interested in where are the asymptotes, what's the end behavior, you know, what is my graph approaching for each of these asymptotes. And let me just graph real quick, just to see an electronic version of this. X divided by x squared minus 1. And there you go. There's an electronic version of the graph, not unlike our own, right? So you can see the asymptotes there and everything. Good stuff. Actually, let me just, I should be able to set the line style defaults, I think, somewhere in my preferences, but I never get around to it. So anyways, thank you for watching. I think we're good. I think we are good. Goodbye, Internet.